This video will be week 1 of our summer algebra practice. I'll be working one problem from each section. Simplify each expression. Number 1 here, we see that we have some distributing to do. Taking the 7 outside the parentheses and multiplying by both terms inside leaves us 49 minus 7k. Distributing this 7 times 6, 42. 7 times minus 2k is a minus 14k. Now we should combine like terms. That's the same variable to the same exponent. In this case, k is like k, and the constant is like the constant. So 49 plus 42, I believe that's going to be 91. Minus 7k minus 14k will be a minus 21k. Technically, we should regroup these terms. We should change our pluses to our subtractions to additions and change the sign so that we can then regroup using the commutative property, but it's okay for us just to say minus 7 and minus 14 will be a minus 21k. Solve each equation. Here we see we have an equation, two expressions separated by an equal sign. We'll begin by distributing on the right hand side. 224 remains the same on the left. Negative 4 times 6k will be a minus 24m, Negative 4 times plus 2 will be a minus 8. Minus 5m will remain the same. Now on the right hand side we can combine the like terms, minus 24m and minus 5m. We'll have 224 equals minus 24, and minus 5 will be a minus 29m. Minus 8. Well, we want to get this variable m by itself, so we should use inverse operations to eliminate our minus 8. We'll add 8 to both sides. Minus 8 plus 8 goes to 0, leaving minus 29m. 224 and 8 is a 232. Lastly, we want to get m by itself. We'll divide by this minus 29 on both sides. Remember, the coefficient, it's connected. Connected means multiply, so we do the inverse operation, which is division. Minus 29 divides with minus 29 to leave 1m. We'll just leave it as an m. 232 divided by 29, I believe that's going to be a minus 8. We should take this minus 8 and substitute it back into our original statement to verify that it is a solution. Next, number 13, solve each equation for the indicated variable. Here it gives us this proportion, a fraction equaling a fraction. It says solve for a. We want to get a by itself. So currently a is being divided by c. Let us multiply both sides by c. We undo division with multiplication, multiplying the left by c and the right by c. Connected means multiply. That's all I've done here. C will cancel with the c. Really, c divides c to leave 1a. And I can leave this exactly like it is. Another way to state this is c times d in the top should show dc over r. Think about c being over 1. D times c is dc, r times 1 is r. Of course, we could rewrite that as cd because multiplication is commutative. This initial statement here would be fine as well. We have solved for a, we got a by itself. Solve each equation by factoring. When it says solve by factoring, we will employ the zero product property. Recall the 4 steps. Step 1, set the equation equal to 0. Step 2, we factor. Step 3, set each factor equal to 0. That is the zero product property portion of the solve by factoring. And lastly, we solve and verify. So in this case, we see we're set equal to 0. Now we could use our big X method. I'm going to skip right to the factoring because this one is a pretty easy one to factor. X squared we know is x times x. If the second operator is an addition, then there will be two of these. It's going to be a plus and a plus. Well, 4 is 4 times 1 or 2 times 2. It needs to be 4 times 1 because we need this 5x in the middle. 4x inside and 1x outside, that yields 5x. Alright, so here we are factored. That's step 2. Step 3, set each factor equal to 0. Now I can say that x plus 4 equals 0, or x plus 1 equals 0. Now solving both of those independently, here subtracting 4 from both sides. X is negative 4. Here subtracting 1. X is minus 1. We could write the answers in this fashion. We could say that x is an element of the set negative 4, negative 1. We could simply say that x is negative 4, comma negative 1. What we should not say is that it's negative 4, negative 1. That's an ordered pair. Should not write it like that. It's an x and a y. These are two x values. We could take these two x values and substitute them into the original to verify. Next, solve each equation by completing the square. Hopefully you remember step 1 of completing the square. We'll collect our variables on one side, our constants on the other. So we need to subtract 3 in this case. So we're left with m squared minus 12m equals minus 11. Next we add in our box number. The box number is going to be 1/2 of our b term squared. Or box is equal to 1/2 of b. That's the coefficient of our linear term squared. In this case, our box, since our b term is minus 12, b is minus 12 squared. Half of minus 12 is minus 6. Minus 6 squared is a positive 36. The box term is a plus 36. It's going to be convenient in this case. Combining like terms on the right gives us 25. On the left side we will factor. The square root of m is m. Then half of this is minus 6. Or the square root of 36 being 6, and this operator goes in the middle. It's the square root of the first term first, the square root of the last term last, and then this operation is in the middle. This is squared. Now we take the square root of both sides. Square root of the left, square root of the right. When you take the square root of something squared, the square root cancels with the squared. They're inverse operations to leave in minus 6. Square root of 25 is both positive and negative 5. We go two ways with this. Taking it this direction. M minus 6 is a positive 5. And then separately, M minus 6 is a negative 5. Adding 6 to both sides leaves us M as 11. Here, adding 6 to both sides, m is 1. I'm going to go ahead and see if we can verify this, m being 1 and 11. Substituting 1 in, you get 1 squared minus 12 times 1. That would be 12 plus 3, and that will be negative 8. 1 minus 12 is negative 11, plus 3 is minus 8. That's true. That verifies 1. Similarly, we could verify 11. Factor each completely. If you're just completing Algebra 1, we didn't do too much of this factor by grouping. But here's the way you do it. You begin by grouping two pairs of the terms. I'm looking at my first pair and this second pair. Find the greatest common factor between each pair. You have p cubed plus 5p squared. Notice they both have a p. I can factor that out. How much? The least power. Go to the least, take it all. So factoring a p squared out of both these terms. P cubed divided p squared is a p, because p squared times p to the first is p cubed. Plus 5p squared divided by p squared is 5. If you distributed, p squared times p is p cubed, p squared times 5 is 5p squared. Plus the GCF between these two terms is 4. 4p divided by 4 is p. 20 divided by 4 is 5. Now you can see both of these have this common binomial factor of p plus 5. So I can factor that out. P plus 5. Look at this whole first part. This whole term. I used to have p squared times p plus 5, but I ripped out that p plus 5. What would remain? P squared. This operator in the middle plus the second one. I had 4 times p plus 5. If I ripped out this p plus 5, I'd be left with 4. This is equal to this, and we will verify by distributing. P times p squared, well, that's p cubed. P times 4, well, that's 4p. Five times p squared, 5p squared. 5 times 4, 20. Alright. Number 41. Factor out the common factor. The common factor they're talking about here, again, is our GCF, our greatest common factor. Alright, notice they all have a k. So I can factor out a k, the least power. A k cubed will come out. Now we have 50, 40, and 80. Hopefully you realize 10 will divide all those numbers. Now typically if the leading coefficient is negative, we'll factor out that negative. You don't have to do that, but as a matter of course, that's what we'll typically do. If the leading coefficient is negative, we'll factor out a negative. Negative 50 divided by negative 10, that's 5. K to the 6 divided by k cubed, that's k to the third. Think about our product rule. When multiplying, we add exponents. Positive by negative, that will leave a subtraction here. 40 divided 10 is 4. K to the 5th divided by k cubed is k squared. 80 divided minus 10, that'll be minus 8. K cubed divided k cubed, well, you would say that was k to the 0, or no k at all there. Notice there was 3 terms initially. 1, 2, 3 terms. We still have 3 terms inside. 1, 2, 3. We could distribute and it would arrive at that. Remember to pause the video between each problem to try on your own. Factor each completely. We have this trinomial, x squared minus 2x minus 80. Let's use our big X method. In the bottom we'll have a times c, and the top b. In this case, a, the coefficient of x squared is 1, c is minus 80, a times c will be minus 80. b, the coefficient of our x term, minus 2. Again, this a, b, and c is from our standard form, ax squared plus bx plus c. A, the coefficient of x squared, b, the coefficient of x, c, the constant. Well, if we have a minus in the bottom, one will be plus, one will be minus. In order to get a negative product, we need 1 plus 1 minus. We know that we're going to have 2 binomial factors, and we know we'll have an x in the first position. X times x yields x squared. We want the paired factors of 80. That's 1 times 80, 2 times 40, 4 times 10. Pardon me, 4 times 20. 8 times 10. There are others, but I think we have the one we need. We want numbers that multiply to give AC, yet add to give B. However, when the signs are different, addition behaves like subtraction. So which of these will subtract to give 2? 8 and 10. Since it's a minus 2, we'll need more negatives. 10 will be the minus, 8 will be the plus. Positive 8 minus 10 will yield a minus 2. These will go here. Lastly, we should divide by a, but in the case that a is 1, division by 1 won't change anything. We could check it. X times x is x squared. X times minus 10 is a minus 10x. 8 times x, 8x. 8 times minus 10 is a minus 80. Minus 10 and plus 8x is a minus 2x. So we see that it is indeed a good factorization. This is the correct factorization of that trinomial. Evaluate each expression. Here you see we have an addition. When we're adding and the signs are the same, the signs stay the same. So in this case it'll be minus 16. 8 negatives and 8 negatives is 16 negatives. Think about a negative number as owing money. If you owe $8 and you owe $8, you owe $16. Find the product. Product is the answer to a multiplication problem. So we will distribute a times 8a. That is an 8a squared. A times 5, that's 5a. Now 4 times 8a, that is a 32a. 4 times 5, that is a plus 20. Combining like terms, 5a and 32a would be 37a. When you're multiplying two binomials together, often you can use the acronym FOIL as assistance. First, outer, inner, last. In this first and last, you can easily identify the first two. A times 8a is an 8a squared, immediately observable. The last two, 4 times 5, 20, immediately observable. What's a little more difficult is this outer inner. They will sum to give this one. The outer, a and 5, is 5a. The inner, 4 and 8a, 32a. Summing gives this 37a in the middle. So this acronym FOIL, it's just a way to remember the distributive property when specifically we have a binomial times a binomial. 2 terms times 2 terms. Simplify. Well, here we see again, connected means multiply. We were doing the distributive property, but we have these radical expressions. I'm going to take 2 times the square root of 15 and multiply it by both of these. Consider each of these radicals to have a coefficient. You might think an implied 1 here, and here we see a 4. So 2 times 1, that's 2. Multiplying the radicands together, that's the underneath part. 15 times 10, that is 150. Plus 2 times 4, that's 8. 15 times 3, that's 45. I think this makes sense. We're just multiplying the outsides together, and it'll stay outside, and the inside, the radicands together, and it stays inside. Lastly, we need to simplify these if we can. Consider the radicands, the number underneath. The number underneath the square root symbol is called the radicand. Consider a perfect square that will go into those. 150, 25 goes into 150. So I can rewrite 150 as 2 times the square root of 25 times 6. 6 quarters is $1.50, isn't it? 45, 9 goes into it. So I have 8 square roots of 9 times 5. I simply changed 45 to 9 times 5 and 150 to 25 times 6. Now I can rewrite this as 2 times the square root of 25 times the square root of 6. Much like I multiplied in this direction, I've just broken up the square root thusly. 8 times the square root of 9 times the square root of 5. Well, we can take the square root of 25. It's 5, so you have 2 times 5, that's 10 square roots of 6. Use your calculator and you will see that 10 square root of 6 is equivalent to 2 times the square root of 150. Plus square root of 9 is 3, so 8 times 3, 24 square roots of 5. And that's as good as we can do. Alright, also you could use your calculator and see that 24 square roots of 5 is equivalent to 8 square roots of 45. If you summed these two, you would see it is the same as that initial statement. Simplify each expression. Well, we're simply combining like terms. When we're dealing with addition, we can just drop our parentheses. If it was a subtraction, we would need to distribute that subtraction, that is, change the signs of everything in the second parentheses. But since it's an addition, we can just drop the parentheses. If it was a subtraction, I'll show an example. If we had a plus b plus c minus d minus e plus f, we would need to change all the signs in this back parentheses. It's much like there being a 1 here to distribute. I could drop my first parentheses, a plus b plus c, and I need to change all these signs. Minus 1 times d would be a minus d. I could write it as subtract d. Minus times minus would be plus e. Minus 1 times f minus f. And this makes perfect sense. We need to, forgetting the 1 for a second, aren't we being called to subtract d? That's what that says. A minus e is an add an e. And minus f, that's what that says. Alright. Now combining like terms. B squared is like b squared. B is like b. And b cubed is like b cubed. We will begin with the leading power first. Minus 5b cubed plus 2b cubed, I believe that is a minus 3b cubed. It has to be the same, b cubed, and it stays the same. Now b squareds. 1b squared minus 7b squared will be a minus 6b squared. Again, it has to be the same and it stays the same. Lastly, 5b minus 6b is a minus 1b. We could just simply write a minus b. And that is it. That's one problem from each section. Take a picture of what you did. You don't have to do the exact problems that I did. You can do any problems as long as you're doing at least one from each section. Email your photo to me. Thanks for watching.